Justin, give me a state of matter.
Liquid.
One word down, 8 to go. Isaac, give me another one. Caden.
Solid.
Those are the three main states of matter. Now, if you are someone who does a little bit more in-depth looking at science on your own, you might know of a fourth state of matter called plasmas, which are basically gases that have extra energy added to them so they lose their electrons. Again, what makes one state of matter different from another is just the behavior of the particles. The same particle, but now it has a different behavior because of how it's held together. There's a fifth state of matter called Bose-Einstein condensates, where basically you get close to absolute zero and matter starts behaving very differently than it was before. That fourth plasmas and fifth Bose-Einstein condensates states of matter we don't discuss in this class. Again, it goes beyond what we need to know, and quite frankly, we want to study the states of matter that naturally occur here on our planet, in this very room. Not what occurs on the sun, plasmas, what occurs in laboratories when we're trying to get close to absolute zero, Bose-Einstein condensates. So there's plenty that we can go over in these next few days. Again, hopefully today is a little bit more of an easygoing day. It's not anything that's too complicated. Kind of lead us into when we have to pick it up a notch. We have to go over the phase changes. Again, today is a vocabulary day for us. Reminder or let you know of what is the different phase changes that occur between different states of matter. Solid to liquid. So if you think about ice, which is solid, then water, the liquid form, what's that phase change called? Not meant to be tricky. When you leave ice out, it melts. So melting. Let's do the exact opposite. I guess you guys don't actually make ice anymore. Back in my day, before the refrigerator did it for you, we had ice trays. You'd fill them up with water, you'd put it in the freezer, and then it would freeze because it's a freezer. So freezing. We're over halfway done with notes. Emma's, you getting sore? Okay, good. On that reading guide, it even mentioned melting point and freezing point, the temperature at which this would occur. On the back side, it mentions something called normal melting point. That's when we have to start dabbling with pressure starting next class, but let's not quite get to that yet. But hopefully, if you just think about water, you can think about what it means to water melt, ice melts, what it means to get water to freeze, to turn into ice. Now, liquid to gas, again, we could use evaporation. However, the preferred term would be vaporization. Again, the reading guide kind of tries to distinguish between the two. So vaporization is when we talk about liquid to a gas. Evaporization is talking about at the surface, some of that water or whatever liquid it is can escape. Ooh, now we get to the last three, which are not as recognizable terms typically. A gas to a liquid. Condensation. I think the best example of condensation would be on a hot summer day, getting out a can of soda, and Wrigley, this would be Mountain Dew, of course, the best soda. And on the outside of the can, it starts to get wet after a while. What's happening is the water molecules in the air, so the water vapor, the gas form, is cooling. It's cooling down and it's condensing. It's getting closer together and forming the liquid version. I mean, in the summertime, you have a dehumidifier in your basement that's trying to do the same thing and take all that gas, water vapor out of there, turns it into a liquid, so then it's not as humid in your basement. You have to empty the dehumidifier every now and then, so there's a visual for that as well. These are the 4 most common phase changes that I have in blue. However, there's 2 more. And these 2, typically, again, because pressure is involved in phase change, and we'll get into that next class period, there are 2 more that occur that go directly from solid to gas or vice versa. So they don't have the middleman of liquid. Solid to a gas is one that was on your reading guide that was due today. Sublimation. If something is said to sublime, it goes directly from a solid to a gas. The best example that I can think of for that is something called dry ice, which is solid carbon dioxide. If you ever go to a haunted house and they have a little smoke rolling through, odds are they're using dry ice, where they take a brick of it, just like a brick of regular ice, except for they call it dry ice because it doesn't melt. It doesn't turn into a liquidy mess and then goes to the gas. It goes directly to the gas phase. And it has to deal with that balance between temperature and pressure for states of matter. So it just turns directly into that vapor. Any of you park outside? Wake up in the morning, you can't just start your car and leave. What do you have to do? Scrape your windshield, right? This time of year? I got a garage. It's not like someone every night throws a bucket of water on your windshield, runs away, and then it freezes. What's happening is it's getting so cold that gas, that water vapor in the air, is directly going to a solid. Anyone know the word? Deposition. There's a solid deposit on your windshield. I hope by the end of this first semester you realize that chemistry is not meant to be a vocabulary intensive course. However, we do need to have enough common vocabulary that we can then communicate with each other about what's going on. And that's why I went over this with you today of just our 3 main states of matter and the common phase changes that occur. Quite frankly, if we were to put a question about this on a test, it would probably be a multiple choice. And it's one that we are meant to give you an easy point. Because this is not explanation to start off with, but we are going to have to explain these phase changes. We will eventually get numerical values for these phase changes. But starting off with, I just want to make sure we're all on common ground when it comes to vocabulary.